Class 11 Chemistry Chapter 3 Classification of Elements and Periodicity in Properties. Hello students, this is your chemistry ma'am Archita ma'am. In this presentation I am going to discuss the discovery of the periodic table, the characteristics of the elements present in the periodic table, and so on. So let's start the topic. Modern periodic law. Modern periodic law states the physical and chemical properties of the elements are periodic function of their atomic numbers. A modern version, the so-called long form of the periodic table of the element, is the most convenient and widely used. The horizontal rows are called periods and the vertical columns are called groups. Elements having similar outer electronic configuration in their atoms are arranged in vertical columns referred to as a group or families. तो हम कह सकते हैं एक पर्टिकुलर ग्रुप में रहने वाले सारे एलिमेंट्स के जनरल केमिकल प्रॉपर्टीज सेम होंगे. There are altogether 7 periods. The period number corresponds to the highest principal quantum number of the elements in the periods. The first period contains 2 elements. The subsequent periods consist of 8, 8, 18, 18 and 32 elements respectively. Now we would discuss nomenclature of elements with atomic number greater than 100. We know all elements were not discovered at a time. With time, each and every elements undergone discovery. The naming of the new elements had been traditionally the privilege of the discoverer, and the suggested name was ratified by the IUPAC. The new elements with very high atomic number are so unstable that only minute quantities, sometimes only a few atoms of them are obtained. Their synthesis and characterizations therefore require highly sophisticated, costly equipments and laboratory. The IUPAC has made recommendation that until a new element's discovery is proved and its name is officially recognized, a systematic nomenclature be derived directly from the atomic number of the element using the numerical roots from 0 and the number 1 to 9. See the first part in the slide. For 0, the root name is given nil and abbreviation n. Like that, 1 to 9, the abbreviations and the root name are given. The examples of the atomic number from 101 to 108 are shown in this slide. Like for example 101, the temporary name it was given unnil unium. Later this element was discovered and has given the symbol Md, that is mendelevium. Like this, temporary names were given earlier, and after finalizing the discovery of that element, the permanent name had been given. Now we would see this. The elements in a vertical column of the periodic table constitute a group or family and exhibit similar chemical behavior. This similarity arises because these elements have the same number and same distribution of electrons in their outermost orbital. We classify the elements into four blocks like S block, P block, D block, and F block. Let us discuss first S block. The elements of group 1, alkali metals, and the group 2, that is alkaline earth metals, which have Ns1 and Ns2 outermost electronic configuration, belongs to the S block elements. They are all reactive metals with low ionization enthalpies. They lose the outermost electron readily to form 1 plus ion or 2 plus ion. Next we move to P block. The P block elements comprise those belonging to group 13 to 18, and these together with the S block elements are called representative elements or main group elements. All the orbitals in the valence shell of the noble gases are completely filled by electrons, and it is very difficult to alter this stable arrangement by the addition or removal of electrons. The noble gases thus exhibit very low chemical reactivity. Next we see the D block elements. These are the elements of group 3 to 12 in the center of the periodic table. These are characterized by the filling of the inner d orbitals by the electrons and are therefore referred to as D block elements. They are all metals. Next we see F block elements. The two rows of the elements at the bottom of the periodic table called the lanthanoids and actinoids. The last electron added to each element is filled in F orbital. These two series of elements are hence called the inner transition elements or F block elements. Periodic trends. There are numerous physical properties of elements such as melting and boiling point, heats of fusion and vaporization, energy of atomization, etc., which show periodic variation. However, we shall discuss the periodic trends with respect to atomic and ionic radii, ionization enthalpy, electron gain enthalpy, and electronegativity. The atomic size generally decreases across a period. It is because within the period the outer electrons are in the same valence shell and the effective nuclear charge increases as the atomic number increases, resulting in the increased attraction of electrons to the nucleus within a family of vertical column of the periodic table. The atomic radius increases regularly with the atomic number. For alkali metals and halogens, as we descend the group, the principal quantum number increases and the valence electrons are farther from the nucleus. Next we see ionization enthalpy. A quantitative measure of the tendency of an element to lose electron is given by its ionization enthalpy. It represents the energy required to remove an electron from an isolated gaseous atom in its ground state. Energy is always required to remove electron from an atom, and hence ionization enthalpy are always positive. The second ionization enthalpy will be higher than the first ionization enthalpy because it is more difficult to remove an electron from a positively charged ion than from a neutral atom. Next we see electron gain enthalpy. When an electron is added to a neutral gaseous atom to convert it into a negative ion, the enthalpy change accompanying the process is defined as the electron gain enthalpy. It provides a measure of the ease with which an atom adds an electron to form an ion as represented by the equation as x electron taking to give x minus. Next, if we see electronegativity, a qualitative measure of the ability of an atom in a chemical compound to attract shared electrons to itself is called electronegativity. The electronegativity of any given element is not constant. It varies depending on the element to which it is bound, though it is not a measurable quantity. It does not provide a means of predicting the nature of the force that holds a pair of atoms together. Electronegativity generally increases across a period from the left to right and decreases down a group in the periodic table. As we know this metallic and non-metallic property in our lower classes, the metallic property means tendency of giving electron. So definitely it's going to increase in that way, and non-metallic property is tendency of taking electron. So it is definitely going to increase in this way. Now anomalous property of second period element. The first element of each of the group 1 and 2 and groups 13 to 17 differ in many respects from the other members of their respective groups. The reason for this exceptional behavior is written in the slide. Small size of these atoms, high electronegativity, large charge by radius ratio, and these elements have only 4 valence orbitals available, 2s and 2p for bonding, as compared to the 9 available to the other members of their respective groups. So their maximum covalency is 4. Diagonal relationship. As first first period and second period and third period is having some similarities of the elements which are diagonally same. A diagonal relationship is said to exist between certain pairs of diagonally adjacent elements in the second and the third period of the periodic table. Moving rightward across the period decreases the atomic radii of the atom, while moving down the group will increase the atomic radii. Lithium and magnesium show similar property. Beryllium, aluminium like boron, silicon, carbon, phosphorus, these elements show similar properties. Hence there is some conclusion points of the above chapter.